Hello. Well, good day to you. Hmm, we're going to continue on with the previous video, and we're gonna actually add to it by building a particle system. So that's gonna be fun. Um, yeah, let's get into it and enjoy. All right, so I'm going to have a template for you from JavaScript, some JavaScript. Now, porting code is pretty common. You may find out in the industry that you're given a JavaScript script and you're told to convert it to Python. That's something that is very common. Especially when it comes to scripts, because scripts all kind of interrelate between different, like seams, log file analyzers is what I mean by seam, SEIM. Uh, so you may have a script in one seam that's based on JavaScript or even C Sharp. C Sharp is a very popular scripting language. Not really scripting, but yeah, it is scripting in a sense when you really think about it. So is Java. Uh, and you need to actually port it over to implement it in Python in some way. And that's very common. So we're going to actually practice with that today. And I've given you a template. Let's actually look at this template. This one you'll have available for you to download, because we're going to actually take code from it and port it directly. So let's look at it, and I'm just going to open it up, and I'm going to copy the folder in it. So I'm essentially unzipping it, and I'm going to paste it here in this folder. I'm just going to do Control V here, and let's look inside of it and look at what this script actually does. Now the script is all based on the index, the HTML, so we can just look at this in the HTML, and it'll show us everything that it's doing. And there is our particle system. Now, this is a script from my game programming design course. That's CS 262, which is an elective. And I would encourage you guys to look into it if you want to know more about what we're doing today. We're not going to stretch too far from what I've already given you. Of course, this is going to be an alternate assignment that you can complete. And then I'm going to add some extra credit to it, so that there won't be an extra credit extension. You're going to get extra credit just for doing the assignment from the video. So let's begin our particle system creation. And one thing that we're going to need is, you notice that we have all kinds of different spheres, and the video I gave you, we're just dealing with one sphere. Well, that becomes a problem when you have hundreds of them, because you're not gonna want x1, x2, x3, x4 all the way up to x100 for the x coordinate for all 100 spheres. That's silly. So we want to use our tools such as looping and object orientation techniques to reduce the difficulty and increase the scalability of our application or script or whatever. So let's begin on that. And I'm going to let's prepare our main. Then we're going to come in and we're going to grab this code. I'm going to tell you exactly what code we're going to grab, and then we will move forward from there. So let's go back to just Python right now, and let's go to our main. Now you notice I have these two folders in here. That's fine, they can be there. We're just going to be copying code out of here and bringing it in here and porting it. So let's go ahead and open up our main. And it looks like we've got, a simple main. That's great. That's great. Okay, we're done with main. Boom. All right, let's save it. Save all. Let's clean up all this other stuff. And boom, there. All right. what we want is we want an object like a sprite object, but this one we're going to be a little bit different with. We're going to call it a particle object. So what I'm going to do is I'm going to go into the code, the JavaScript code, and I'm going to grab out particle.js. And what we're going to do is we're just going to rename that to Py, and we're going to port everything in it to Python. And so you guys will be able to, follow along with me as we do that. So we're going to go back to main here, and we're going to paste it in here, and then we're going to rename it particle.py. Now that's going to be in JavaScript, but that's fine. We will modify it. All right. Now we see right off the bat that we have some specific things here, such as what is a vector. And what we're going to be doing is we're going to actually create a vector class to port all this code to Python. Now we're probably going to get rid of some of this code. In fact, let's get rid of these get polar stuff. That's going to be gone. So we have the life cycle of the particle in here. We have a draw. This is going to be our update and draw functions that we'll call from our main. And then we have a function that renews the particle, and then a function that applies some force to the vector class. So that means that we need to grab the vector class and port that. So I'm going to go ahead and do a save all here for the particle. I just took some stuff out that we're not going to use. I'm going to go back into here, and I'm going to grab out the math vector class. Now we're going to strip this one out heavily. So let's just copy it, and we can come back to it after we strip it out and add back anything that we stripped out that we shouldn't have. Yeah, okay. So let's go ahead and rename this to .py, and let's call this p vector for just a vector means a direction that describes X and Y. So we can talk about that terminology vector here shortly. And then let's go ahead and just kind of port some of that stuff. So we're going to go in here to this vector class, and you know what? Let's get rid of all this stuff. All this stuff except for, all this crap can go. All this crap can go except for this. And then what we're going to do is let's rename this p vector. And we're going to call this class p vector. And remember, we're going to get rid of this. And let's totally redo our indenting. Oh, it looks like our indenting is okay. All right, now what we need to do then is we're going to say, we're going to make these private. And we don't need pi. We just need X and Y. Okay, that was rather simple. I'm probably creating the class wrong. Typical. Let's go ahead and reference that. Syntax and semantics. Python object, I always forget which language is which. It's typical. Okay, what am I doing wrong with that? Class my class, that's fine. Oh, we're not doing the init. Okay, let's go back to there. You can see why I get kind of have this confusion when it comes to what language I'm in and working with, and what are the syntax and semantics of whatever language I'm in. And that's what Google's for, guys. I mean, I don't really put it in my mind too much, like totally memorizing a language, because it's not needed. Once you understand one language, you can pretty much, go to all of them. So let's look at this example. What I got to do a def init. Okay, a def init. Okay, and then that needs to be tabbed in. And then we need to do some getters and setters for this. There's something else I'm missing. No? It's all looking good. Oh, self. All right. That should be fairly ported. Oh, guess what? That's another thing we got to do, because that's not available on Python. We got to actually send X and Y here in the init function. Oh, so I just ported it now from JavaScript to Python. Ported it. I just port it. Ported? Okay, whatever. Now let's see what else that I've got. Self. Oh, I didn't apply self to this. Okay, we got it. Now let's do this. Let's def get x return self return self dot x. Oh, yeah, that's Java. Let's see in JavaScript. Okay, let's do this. Let's do this for get y. And then I'm going to tell you what a vector class is. All right. And then let's do the set. Okay, and one more last thing, and then we do our copy paste. Modify all that to y, and then y. All right. Oh, tab. Cool. That's ported our vector class. So let's talk about vectors. When I talk about vectors, it's totally different from when I talk about vectors in computer science. It's totally different from the vectors that in some programming languages, they use vectors differently than a vector that I'm talking about with 2D programming, 2D graphics programming. So let's say that we want to keep track of a location on our canvas. And let's say it's there. So we can use a vector because it's just got an X and Y coordinate in it. So we can use vector to refer to location. So where is something on the screen? X and Y, location. Then we can also use the vector for acceleration. Acceleration object, because what we can do is we can use X and Y to describe how fast something is going. So let's say that we have an X of equal to 0.5 and a Y equal to 0.5, and that's our acceleration vector. We can have our location vector. Let's say that it's 5, 5. So that's our location vector, and then our 5, 5 locations there. But then we have an acceleration that we're going to add to our location. So location x will be equal to location x, every plus x, the vector x. So this would be vx, vy, or acceleration x, acceleration x, vector x. Okay, so this will be acceleration x, and so our location x will be always added to our acceleration x, say every frame. every time we update our game loop. That means then that every two updates, this location moves by 1 pixel in this direction. So it's just basically showing a direction. If it's a 1 and a 1, basically it's going faster in this direction. But what if it's a 1 and a 0.5? A 1 and a 0.5 means it's going faster in this direction, but it's going slower in the y direction, so it's going in that direction. So what about a -1 and a 0.5? Well, that means it's going that direction. -1 that way, and then 0.5 down. So this is x and this is y for the change. Acceleration x, acceleration y. So that's all a vector is. And it can be your location and your direction. And so we'll be using p vector for our location and our acceleration velocity vectors. And so I'll be using that terminology. And basically, what is it? It's just a point and a reference. It's just a point and a description of direction. So we're going to use them in both different ways, depending. They can be used in one way or the other. That is our vector class. Now let's go ahead and do a save. That's all done. Let's do particle class, and what we're going to do is we're going to say from p vector import vector. Okay, now let's do this. This is our particle. What we're going to want is we're going to actually do this. We're going to do def particle. Let's do a lowercase p, just because I'm lazy and I don't want to hit the shift button. And then what we're going to do is let's get rid of that. Let's do a tab. That's not a tab. Is that a tab? Okay, I guess that's a tab. That doesn't really look like a tab. We will see. Oh, I need to zoom in. That's why it's not looking like a tab. Oh, why did that turn to... Okay, that's fine. All right, that's a little bit better for you guys. Okay, and then let's give you another look at p vector. I'm just going to take a quick pause here so that you guys can take a good look of our vector class. Now we're going to go into our particle class, and we're going to need an init function. So I'm just going to grab this init, go here, paste it in, and then all these things are going to go into the init function. So a particle is essentially one of our spheres that we're going to draw on the screen. And we want it to move differently based on lifespan. We're not going to use mass. We're not going to use angle. So we're just going to have XY, its starting location, how tall it is, how wide and tall it is, then what is the direction that it's moving, and then its lifespan. And when we accelerate it, we'll do that in the update class for acceleration. All right, so then that means that we need a location variable that is a vector that is going to describe where our particle is going to be at. And this is going to be equal to p vector, and we're going to pass it x and y for the init. And let's come back to why we're not, p vector is not defined. File save. Let's go back to our file folder, pvector.py. Okay, we will deal with that later. Maybe it's just getting confused from all the other code. So we'll come back to that. We're going to have a lot of things that we have to fix as we progress. So this is going to be self.acceleration. So let's just tab that in. And you know what? Let's just copy this and do this. Now we're not going to use the angle. So that's going to be out, or the mass. So let's just get rid of that. Well, we're going to have a lifespan because we need to know, because if we're doing a particle system and like say a machine gun particle, like the bullets, there's a certain time where we're going to want the bullets to stop drawing on the screen or the particles to stop drawing on the screen, and that's your lifespan. So how long do the particles draw on the screen as they're being dispersed? And that's what lifespan is for. Okay, then we got this. Let's do this. Let's comment this part out. We're going to come back to this. And then what we're going to do is let's just take this out, cut it, and go all the way down here and paste it. And then while we're at it, let's get rid of this. We don't need this. We don't need this or this or this or this or this. I'm getting ahead of myself. Let's not do that yet. Let's modify these functions from top down. So we'll get to there. Okay, so then now we've got a few things to do. P vector. We're going to tab this in. Get rid of the new statement. P vector. We're going to have to change this to direction.getX and direction.getY. Because direction is going to be a vector. A P vector. What are these? So we're just doing getX and getY. Particle height, particle width, that's just a number. Like 16 pixels wide, 16 pixels tall. X and Y is just the location. Direction, again, a vector of the direction that the particle is going to initially be going at, and that's your velocity or your acceleration, and then that's going to be added to the velocity. Lifespan is going to be, I already explained that, so we can move on from that. Okay, let's tab this in, tab this in, tab this in, boom, boom. Get rid of some of this JavaScript code. Get rid of this JavaScript code. Boom, boom, boom. Get rid of this JavaScript code. Boom. Okay, we're going to have to figure out what's going on with this P factor thing. Let's put P there because it's supposed to be from P vector, import P vector. It might be import P vector from P vector. We'll see. I'll probably pause and play with that. Let's go ahead and continue on with our porting. So this is the renew function, and instead of saying this dot, we're going to put self in here. That's going to tie it to the object for Python. And then we're going to say just def renew. And then we got to do our thing here. Angle, we don't need angle. We're going to get rid of angle. Okay, get rid of this stuff, that stuff. That's all JavaScript stuff. Let's tab this in right. Oh, that needs to be self, so let's go ahead and fix all those. And you know what? Let's do this. Let's go to edit, replace in files. Let's say this and replace with self. Okay, 22 results in one file. Okay, and let's do all of them. Did we do all of them? I think we got them all. Cool. Okay, then we got to fix up our tabs. Okay, I got them lined up with our tabs properly. Then we got to get rid of this JavaScript stuff. Okay, now we've got a few things like this dot set. We didn't build a set function on p vector. So a set function will be something that sets both x and y. So let's add that to our p vector. So let's go over here to p vector and let's add a set function. And that's just to set both x and y. That's all it is. Okay, self.x, underscore x equals x. Self.underscore y equals y. Okay, that takes care of our set. File, save all. Okay, now let's go back to our particle. We don't need angle. That's gone. Okay, there's our renew function. Done, imported. Okay, now we have update. This is going to be gone. We're going to do def here. And then we're going to put self here instead of the this. Self. We don't need the FPS. Let's get rid of the FPS. And let's get rid of all this other stuff here. This is going to be what we call from the game loop. And this add to, let's rename this, you know what? Let's comment this out for now and come back to it. Let's get rid of all this stuff. We're not going to use this add to. We're going to actually come back to that. Let's comment it out. And we're going to hard code that directly instead of using a function. That's just going to be updating the velocity. And we can look at the old add to function from the old p vector and add it to the new p vector, which is probably what we'll do. But again, we'll come back to that. Okay, lifespan, every time it updates, we reduce the lifespan by 2.0. Let's go ahead and port this draw function. And we got to put self in it. Then we've got to, get rid of this stuff. Okay, get rid of this. Get rid of this. And then all this is going to be commented out. We're going to take this and we're going to have to do it in the canvas based on Python. And we may have to pass in the canvas from Python or from the game loop in our main. Okay, and we're going to update our main from our previous assignment shortly. So we're going to come back to this draw. Now let's port the isDead function. And then that's going to have our self. Okay. And then all this does is sees if we have our lifespan for our particles run out so that we stop drawing it. That's all it is. So we draw it on the screen for a particular amount of time. As long as the lifespan is less or greater than 0. Once the lifespan is done, then we stop drawing it. So that essentially that's something that we set when we instantiate the particle to be drawn on the screen. Okay, now I think we just got to make sure that these tabs are right. That's what was wrong. Okay, now true. I think that has to be capital T for true. So porting is pretty easy, guys. It's just going from one language to another. And, oh, yeah, we do have tab issues. Oh. There we go. Okay. Now why don't you like me? Why are you being a stinky turd? Oh, the indents are totally blown out. Okay, well, if that happens, then what we got to do is this. Oh, I know what's wrong. It's just because I don't have any code up here. So I can just do this. X equals 4. And that's just a placeholder, so it doesn't. So like we can say that that function's done. Yep, I think we're good. We have the initial port of our particle. Now here's what I'm going to do. I'm going to pause for a little bit, and I'm going to see why we are not reading p-vector. And then I'm going to come back, tell you what's wrong, and then we're going to continue on into main so that we can draw some particles initially. Then we're going to build a memory pool, and then we're going to disperse particles from the memory pool, and then we'll have it nailed, essentially. So I'll see you guys shortly. Okay, no, it was just the IntelliSense that I've got probably a clashing extension that's causing this problem with the p-vector not being recognized. So I just added the type ignore command so it would ignore the IntelliSense throwing that warning. So we are now... I've tested the p-vector, so the p-vector class is working, which means it's working here. All of this is good. I think it's time that we start, we actually get a particle drawn to the screen. And so let's go and flesh out main, which means that we're going to open up the previous week's module that we did this on, and we're going to grab that main. Oh, no, it's the other one. Oh my goodness, where did it go? What did I call it? Okay, guys. Yeah, that wasn't, that was a quick break and a quick re-break. So guess what? I got to go find that code because I have no idea where I put it, and I'm not going to let you go through that excruciating detail. I'll be right back. Okay, I found it, and I'm going to just call it gamecode.py, and I'm going to make that available for you guys to download as well with this zip folder for the code that you're going to port. So this is the game code. I'm just going to grab all of it, and then we're going to hack and slash. That's my favorite term for getting rid of stuff. So now we're going to go back to our main that we're working on, and we're just going to paste over everything. And we're going to look through here. Okay, I don't need this guy anymore. This is all good. We need the import of Tkinter. We need our game loop, our canvas. What we do not need is all this. Let's comment this out because we will add that to our particle class. Let's get rid of this. Actually, let's do this. This is gonna all this. Let's cut it out. Let's comment it out. Cut it, and that's gonna have to go into our particle code because we're gonna be doing that in our particle update code. So let's go into our update. And let's just add that in there. This code is actually doing what this line 30 is doing. This guy right here. So we can just get rid of that. It's just setting x and y acceleration to 0. Because we're using a p vector now for our acceleration vector. And our location is just another p vector. So we're using location as an x and y coordinate where we draw our sphere, and then our acceleration, our velocity is how we move the sphere. So the only thing that we'll probably use here is we're going to do the add functions, and then we're going to check the edges. Oh no, we're not going to do the edges. Not for this example. But we will probably do maybe some kind of collision detection, so let's leave that there. Okay, let's see, where are we at? I think... Okay, we just need to go into the init now and get rid of all of this. We don't need it. We're going to be redoing that. Okay, what we want to do is we want to get just one particle done and moving on the screen. That's it. Just get one particle. And that will be testing our particle. Then we'll get our particle system, an emitter class that'll do our memory pooling and be responsible for emitting our particles. So let's get our particle moving and updating. What we're going to do is we are going to have a particle that we create in the init that is going to start at a location. So we're going to have a location for our particle. No, that's all done in the particle. We just need to create the particle and update it. Everything else, the location, acceleration, velocity of the particle, is all done in the particle class as it should. So we just need to create a particle. So I'm going to say here that test P is equal to particle. Okay, now let's get into what we need to actually send to the particle. We need to send all this. So let's just put that right in here and we'll hard code it in. And we got to do our import from particle particle. Come on, spell it right. Particle import particle. And then let's do our type ignore so we don't have to deal with our IntelliSense yelling at us. Okay. The game loop, we will do our update and our redraw. But let's get to the instantiation of the particle. That means that let's start it out at location 5 and 5 on the screen. Let's say that the particle width is going to be 16 and the height is going to be 16 pixels. And let's say that the direction is going to be 0.5 and 1. So it's going to be going down pretty steep and to the right. And then our lifespan, let's do at 300. Okay, does that take care of all the particle? Okay, good, good. The renew, the update and the renew, the draw is what we actually got to really deal with. We're not going to deal with renew. We'll come back to that. That's for when we reset the particle to begin again from a memory pool. So this is like a sort of instantiation. So you got to instantiate in the memory pool, and then once a particle's lifespan goes away, then you got to renew it from the memory pool. So this is way later that we'll deal with this. The main things that we got to deal with now is the update and the draw. So how are we going to move the particle, and how are we going to draw the particle? So let's deal with the draw first, and that's going to be from our game loop is where the draw is actually going to be, and it's going to be this right here, the create oval. So what we want to do is we need to actually send the canvas variable to the particle so that we can draw it to the canvas that we've instantiated here. So it needs to have access to the canvas to draw it. But the oval, the drawing of the particle, is going to be done in the particle's code. So let's do this. Let's copy this and let's comment it out. Okay. And let's go back to the particle, and the draw function is going to need the canvas. We're going to need to send it to canvas. And then what we're going to do is we're going to draw the oval from the canvas. So the draw is just going to do this. And we don't need to do self dot because we're passing the canvas. So we're just going to say canvas dot create oval. Now self underscore x, self underscore y, and then self plus self underscore x plus what is it that we called the particle width and height? Width right here and height. Oh guys, look at what I did. I messed this all up. We're going to have to go through and change these all to underscores. Let's come back to that code later after we go through and do all this. That's just appropriate for Python. Okay, got it. So we were in the draw function. We're going to create the oval, self x plus self width. And this is so we're not hard coding it, and we can, when we instantiate a particle, we can make it as big as we want or as small as we want, or we can randomize the sizes of it, the size of it. So it, you know, hey, that's what we want, to not hard code as much as possible. Okay, notice I'm putting my underscore y there, self dot underscore height. I think that's done. I'm going to pause here so that you guys can take a good look at the create oval that we put into the draw function. I think it's good. We can get rid of this x equals 4 as a placeholder. And we can get rid of all this stuff because that's JavaScript stuff. Okay, now, when do we call the draw? We got to update and then we got to draw. So in our game loop, we've got to call the particle update. So we're going to say test.update and then test.draw. Now here's the problem. Test is not part of the class. So we got a few things that we got to change here. We got to do this underscore underscore for that. So the canvas itself, and then here underscore underscore for the main window, underscore underscore there, and then this is going to be self dot underscore test. That's the test particle. So right here, we're going to say self dot underscore test update self._test draw. And then the draw needs, we need to pass the canvas, self._my canvas. Okay, I'm going to pause real quick. And let's look at this. Oh, we got to do our underscores here because I didn't do it at the beginning. And I'm probably going to have you redo your assignments if you don't do your underscores, by the way. I probably already told you to redo them. But, yeah. Okay, whatever. Oh, another underscore. Okay. Oh, another underscore. Another underscore. Look at that. We're just going crazy with the underscores. I think it's looking good. Okay, let's look in the particle code. And let's look at this update function. What is it needing? Nothing. So it's good. We are going to have to play with it, though. Okay, now let's look at this draw function. What is it needing? It just needs the canvas. And that I sent. So now let's just to see if it actually does it. Let's see if it actually will draw an update. So let's just set a breakpoint here. And let's go ahead and start debugging our Python file. Oh, underscore is missing up here, right here. Underscore, yeah, I know. We'll get to that. Underscore here first. And the init function is probably going to die on us, so let's set a breakpoint in there too. Let's hit stop first. Set a breakpoint here just to examine it because we got lots going on. Okay, let's see. We got the main window good. We got the canvas good. Here, let's do a step into here so we can test this and see what's going on. Oh, it totally died. So it does not like particle import particle. For some reason, I am not able to instantiate particle. Seven we're given takes 0 positional arguments. So that means that the init, I may have not finished. No, the init. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, what are we doing? 1, 2, 3, 4, 5, 6, 7. Oh, okay. So when this happens, what I like to do is I just like to copy what is expected and what am I sending it. And then I just comment it out. That way I know I'm getting my arguments correct. So we've got X and Y, XY, 5, 5, width of 16 by 16 pixels. We have direction. Oh, I'm doing an XY direction, which should be a P vector direction. Okay, let's do this. Direction equals P vector 0.5 and 1. Okay, so then we're going to just, instead of passing X and Y, we're going to pass in direction now. And then our positional arguments should be good. Okay. Let's try it again. Okay, go through it. Good, good. Oh, still don't like me. But 6 were given. Why? X, Y, 5, 5, 16, 16, 16, 16. Direction, 300. But it's expecting 0. So there's something wrong with the init. I'm wondering if 1, 2, 3, 4, 5, 6. All right, guys, this is pause time, and then I come back and I tell you what I did wrong, and then we'll continue. I don't want to take you through all of the excruciating details. I'll be back shortly. Okay. Well, that was quick and easy. Seems as though I didn't finish getting all the JavaScript out of there. It's these two open close parentheses, which we have the init function for. So that goes away. And then I probably need to reset my tabbing. There may be some issues there. Let's look at what is I got. Oh, class particle. That's the next one, guys. Class particle. Okay. You're probably wondering what I was doing. I was being silly. Okay. Hey, we got there. Now we know. Class particle, blah, blah, blah. Okay, we're good. All right, hit stop. Let's try it again, and let's see if we can't get over it. And we'll look in our locals just real quick to see if we've actually got our particle correctly instantiated. Step over. Let's look in our locals. No. Why are you not showing up? Oh my gosh. Should be self-test. Self-test. Oh, it's in. Oh my gosh. It's not even in here. Can't be in the globals. The hell with it. Let's just set a watch. Let's add a watch. Okay, it looks like, yeah, particle object. Okay, so it's good. Okay, good. Boom. Now we got a problem. Yes. Why was I being stupid there? Look at that. That's a library specific, not something I create. So we got to get rid of the underscores there. I think, okay, we're ready to test it one more time. Good. Okay, now we update from the gum. Okay, so this is an update for, and let's step into, it's an update for this guy. Looks like that all good. Step into, let's see if canvas is seen. Is canvas good? Oh yeah, canvas object, we found it. Okay, so that should have worked. Okay, so we've got something going on there because it's not actually drawing it, or maybe it went off the screen so fast we didn't see it. But we've got a few things probably to deal with, but let's just look at it and see if we created our oval, canvas create oval. Let's see if we've got that. And let's get rid of this guy because then that might be causing some problems. The canvas clearing, so that we can determine whether we're actually drawing. Okay, it looks like our drawing is not happening. Okay, so then that means we need to do a step into the draw and examine what's going on. So let's step into it and let's look at this. Is X got a value? Oh, that's why. I ported it wrong. We should be using the location X here. That's why this isn't working. Well, you know, little step by little step, and that's what debugging is for. We have our location here. So we should be doing self.location _ location dot get X. And then this one should be self dot underscore underscore location dot get y, because that's our p vector for the location of where we're drawing our particle. And remember, we're going to use this p vector for moving the particle, the acceleration and velocity. So when we draw it, we use the location p vector. And we get x, get y. That's where it's drawn. And then we've got to use, this guy needs to change to self dot underscore location dot get x. Jeez. Okay, now this one right here is going to be self dot underscore underscore location dot get y. Okay, so let me just kind of do a side scroll here so that you guys can see kind of the whole thing, and pause as I progress. And then by my luck, we'll have to change it because it doesn't work. Okay, that should work, because p vector has a get x and get y, and we're using location. We're setting the location when we instantiate a particle. So this location is based on the x and y we send it. And that's what we're drawing it based on. So let's go ahead and just run this and see if it works. There it is. Cool. We're good. Okay. It's not moving though. It's drawing, but it's not moving. So let's look at our update. And our update has this add function for the acceleration of the velocity. So we need to add to our p vector an add function. And let's actually port that from our old p vector class from JavaScript. Oh crap, I don't want that. Open with Visual Studio Code. Good. We just want the add function. Let's go ahead and grab the add. Oh, we don't want particle. Duh, we want the vector class. Not that folder. This one. Oh, I did the wrong thing again. Open with Visual Studio Code. Okay. There we go. Okay, this is add to. Let's go ahead and do this. Let's just copy it and we'll port it. Okay, so all this is doing is adding the direction of movement. It's doing your plus x or plus dx, change of x, and change of y. That's all it's doing for your velocity and your acceleration. So we're going to do here, we're going to do an add. We're going to rename this add def add, and we don't want that. Oh wait, this is a function, so we do send it an other vector. So this is the other vector that we're passing it to add it to the current vector. The current vector is x and y. And so this is going to be self underscore x, and let's get the indenting correct. Let's put this here, indent this. This is going to be self underscore underscore. Let's do that. Other dot get x, and then other dot get y. And we're going to have to test this and make sure this works. And let's back this up, make sure our tabbing is good. Our tabbing is good. Let's call this just add. And why is it yelling at us? Oh, I didn't put the self in there. There we go. Okay, so it's just adding the x and y coordinates for direction of movement. from another vector. And the other vector will be acceleration or velocity, and we'll be assigning acceleration will be added to, or velocity will be added to from acceleration. Location will be added to from velocity. And we did that, hard-coded that from the previous video that I showed you. All right. We have our add in. So let's go to our particle code. And so when we update our velocity, we're going to add it from our acceleration. When we update our location, we're going to add it from our velocity. And then we got to reset the acceleration and reduce the lifespan. Then we're gonna have maybe some collision detection later. So we may end up doing maybe a bounding box with a rectangle that's on the screen. We'll see. But the key here is just to get the update function working. All right. Let's test it. So I'm going to set a breakpoint here. Oh, the breakpoint didn't get set. Let's do that again. Okay, let's do a step into. Okay, we're going to add to the velocity. So when we look at the velocity, it should be 0, 0. The acceleration, we can look at, oh, I see a problem right now. Look at why it's not working. Because I didn't do the underscores. See, one little addition from the beginning code. It's always important to do things correctly at the beginning, because then you got to do all this little fixing. Okay, now let's go ahead and run it again. Step into. Okay, so our velocity, let's see that if things change. Let's do a step into here. Okay, the other is at 0.5 and 1 is what we're sending in for direction. And that is when that's this guy right here. We set a direction of movement initially. So that's our beginning acceleration. And that's going to be added to the velocity. So the velocity is the current object that we're adding that acceleration to. So the velocities x and y would be increased by the acceleration value, which is, in this case, when we look at this other vector, y of 1 and x of 0.5. So when I do a step, when we come back, we should look at velocity, and you can see it's got 0.5 and 1. Now location right now has 5, 5. So when we add the velocity, it's going to be changed by that 1 and 0.5 direction. So once we step over, let's look at it. Velocity is 0.5x. So location's x should be 5.5. Go back to velocity. Velocity is 1. Location's y should be 6. So it should be 5.5 and 6 when this is done. We look at location, good, 5.5 and 6. So it's moving in the direction we want. It's updated. We reset the acceleration. And now our velocity is set and it's constant. And so that's just initializing the movement. We haven't decided to add any acceleration to it. We have it moving in a constant velocity. Okay, we should see something on the screen come out. Okay, well, obviously we got some issues because it's not moving. Interesting. So let's look at what we are doing wrong here when we do the location.add. Because location should be updating every time by that new 6 and 5.5. So when we do our initial draw, it should be 5.5. And then when the draw is called again through the game loop, it should be increased by that directional movement based on its current update. So we should be able to intercept that and look at that behavior happening. Okay, our first one, location, is 5.5 and 6. Okay, I'm going to hit just continue here. And what it'll do is it'll continue running back to the next game loop call where draw is called again from the game loop. And we can track what's going to happen. Oh, it dies because of this attribute error. So the game loop is not called again, probably because I got that underscore there. I probably did something wrong. Yes, I did. Maybe not. What did I do with game loop? It's saying that it doesn't. That was weird. Game object has no attribute underscore underscore game loop. Oh, there it is. I messed up my timer call. I'm being an idiot. I went a little underscore crazy because that's just a function. We don't need, it's not a property or it's a method. So we don't need the underscores in front of that. So let's get rid of that. Now we should see it moving. So let's go ahead and, let's hit continue. Boom. Location now is 6 and 7. So it increased. So its velocity is increasing. So I'm going to hit play or continue, and then I'm going to look at it. Oh, we got movement. We're good. Okay. So we've got it. We've got this scaled now so that we can really take this off the hook and have some fun. And that's what this is all about with object-oriented programming. I actually had a student ask me, what's the point of object-oriented programming? Well, you can see that we took something really simple that we did in our previous game loop code, and to have it so that we can have hundreds of particles, we need to make it scalable with object-oriented programming techniques. So let's get this, let's do one last thing. Let's get this so that it is, when it updates, it bounces off the screen, off the corners, and then let's, we're going to modify this update, and then we got to go back to main, and we've got to actually have the delete working, okay, so that there, it's now moving appropriately. Now let's do this. Let's go back into particle, and let's add in where it bounces. We're going to bounce it. And we're going to have to do a few things because it's going to be velocity that we're changing now. And we're going to be looking at location. So this is now going to be location dot get x. All right, and this is now going to be velocity dot set x. And then what are we setting it to? The current velocity dot get x times -1, so that it goes in the opposite direction. And then we can just copy this and do the same thing with the y. Set y, get y. And then this is going to be location Oh, it's underscore underscore, isn't it? Yeah, underscore underscore. So let's add our underscores real quick. Underscore 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 underscore. Blah 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 blah. Okay, come on, we're going underscore crazy. This is going to be underscore underscore eventually, but it's going to be location dot get y. Okay, location dot get y function, and self dot location dot get y function. Velocity, 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 velocity. Good, good, good. Okay, this should now bounce around the screen. Let's in main. Let's make it move faster. So I'm going to set a 2 speed to it. And then we're going to see it bounce around the screen with a little bit more speed. Let's just verify that it's bouncing around the screen. Okay. Good, good, good. All right, guys. We've got the initial thing scaled now. And now we're able to really implement some heavy-duty cool stuff with our particle sprite. It's a sprite, and you can actually add an image so that you do, instead of draw, create an oval, you do a draw image here instead. That's totally doable, so that you can have total sprites with images drawn instead of ovals. So you can easily improve this. So here's what we're going to do is next one, when I come back, I'm going to pause this and we're going to be moving into the next portion of this video, which is where we're going to be emitting the particles. So we got an emitter where we're going to create a memory pool, and then we're going to shoot the particles out, bounce them off the screen, and then I think we are far enough along for me to be happy where you guys got something fun and a little bit more than what the book gives you. And also, some of you guys who have taken my other classes, this is a little bit more than I usually do for this portion of the course. So I'll see you guys shortly. And then we're going to get onto the emitter class and start our emitter particle system. This is how you can do like fireworks, machine guns, all kinds of cool stuff. I'll see you guys soon. Bye. Okay, let's get going on our emitter so we can tie this, get this all the way done. And that's going to be in that code that I've got prepared for you in the template JavaScript code, and it's called emitter.js. So let's just copy that and let's paste it out here and rename it to Pi and go and import it. Okay. It's porting fun time. Okay, now, oh, this one's got a lot going on. I don't know about angle. I don't think we need angle. Angle is for more if you're doing like, making it rotate. So we're not going to be rotating spheres. You can implement that for translations for like images that are square or something like that. But a sphere, it's, you could still rotate a sphere, but it's not really needed. So let's start this out well, class. So I don't do that again. Let's call this emitter. And then let's go ahead and do a find replace. Let's go to edit, replace in files. We're going to find this in self. And we're going to do, looks like replace all. Why aren't you working? Okay. Oh. There's 66 occurrences of that? Oh my god. Okay. Things are going to get a little funky here. We're going to have some fun porting. Let's do this. Let's get rid of this. Let's copy this. Get rid of it. Down here, we're going to be doing our init. Okay, and no, not any of that. No. Let's paste that in, and let's do this. Boom. Boom. Okay, now let's get these guys ported. Oops. Oh my goodness. Okay, so we need these guys to be tabbed in appropriately. And I don't think we're going to use mass, but we'll see. No, I don't think mass is going to be used. No, let's not use mass. Let's get rid of mass. And angle. Let's get rid of mass and angle. So these guys, mass can be gone, and angle can be gone. Okay, now let's do our underscore. And then we'll talk about this class once we get it ported. Because it's sort of like, you can treat it like a sprite itself, but it's a sprite of sprites. It's a particle, it's a particle of particles. So we're going to have a memory pool in our emitter. This is going to be our list right here that we're going to create as we progress. Let's do this as p vector. Port that. Port this. P vector. Port this. P vector, and let's go in and copy our P vector import from our particle code. Control C, go into our emitter, boom. Control V, throw in our colon here, boom, good. Do we do a lot of applying force in this? We can grab it later. Let's just get rid of it for now. Okay, now what we're going to do is we're going to build the renew function. So let's call this def renew. Now this is actually not needed. Let's get rid of that. We don't need that because we're not going to have to renew multiple emitters. We're going to just renew particles. Okay, now we're definitely going to need an update function because we're going to call an update for all our emitters. And the emitter is basically just a list of particles. So when we create an emitter and start drawing on the screen, the emitter is going to be responsible for drawing all the particles that are in the emitter. And so then we can have it emit, we can have fireworks, all kinds of different things that we can add to it. We're not going to need FPS. So let's just go ahead and get our def update good. Get rid of some of this stuff that we don't have in Python. And this guy. And this guy. Good. Let's do this. We're going to come back to this. And let's just put a placeholder in here. X equals 1. Just so we don't have the errors. Okay, we're going to come back to the update. Now we're going to have a draw function. Okay. Get rid of all this other stuff. Good. Good. And we're going to come back to this as well. Comment it out. Because we got to get our list built correctly before we can update all our particles that are in our list. So we'll put a placeholder in here again. Done. Get rid of that. Okay, now we need to add particles to our emitter. This is going to be the function that adds to the list each particle, the direction, and how many particles we're adding at once. And this is going to be our memory pool. This is what's going to be accessing our memory pool. So we are going to come back to a lot of this code. And basically, it's time to comment this out. Put in a placeholder. Good. Comment all this out. And we'll port all this code over later. Let's get rid of this stuff too. We don't actually need this stuff. Okay, polar X and polar Y, we do not need these. These can be gone. We're not going to be using these. The isDead function, we don't need that. We're just using that for particles. Now the pool memory function is very important. This is where we're actually going to pool the memory on our list. And it will be only called once, and it will instantiate the memory pool for the emitters, all the particles that are in the list of the emitter object. So let's go ahead and let's do this for now. This is actually going to be called from the emitter class right off the bat. So let's leave that. Let's comment this out here. That's at file scope. And then this function def pool memory, we will have as our memory pooler. And again, we're going to port it to Python. And let's go ahead and comment all this out, and our placeholder. Okay, so now we need to add the self to each of these. Okay, there's an error. Still got to add self. And then the self to this one. We may have this as a standalone, we'll see. No, it'll be self. Yeah. This is now some code that we're going to get rid of because this is all JavaScript. Put your colon out here for the init function, and then get rid of all these things that are all JavaScript. This is all C-based type code, or C++ as well. So we don't need those semicolons in Python. This right here is the next bit that we need to deal with. This is our memory pool list. So this is going to be instantiating a list of particles, and then our memory pool is going to instantiate that list of particles. But we're not going to be, we'll create 300 particles, and we'll be continually recycling those particles as we emit them. And that's kind of the whole point of the emitter object, is to do that, is just to instantiate a whole bunch of particles and emit them out, and then stop drawing them when their lifespan is gone, or renew them when it's time to renew from the memory pool, and redraw and re-emit them with a reset of their starting point, etc., etc. So this is going to be instantiating a list. Let's go ahead and let's look at Python object list example. Why are you being a stinker? Okay. Okay, there we go. All right, yeah. Okay, so as I thought. Okay. So we're going to instantiate that list. So we're just going to say right here, we're going to say list, and we're not going to tell it what type it's going to hold. That can be done because it just holds references, so it doesn't really matter. Did I do that right? Oh, we don't need to do that. We can just do this. You know what? I'd rather do it the other way, where you actually just say list with parentheses. Let's try that first. Yeah, I like that better. Okay, so now here's the whole goal, is let's just make sure that the init function is working when we instantiate an emitter. And what we're going to do is in main, instead of test being a particle, test is now going to become an emitter. So instead of particle, we're going to say here emitter. And let's go up here and say, instead of from particle, import particle, we're going to say from emitter, import emitter. And we're no longer going to have particles in our game loop, or our main game loop. So let's say here emitter, and then let's go look at what the emitter needs as arguments. Okay, so it needs an X and a Y, a starting location for where the particles are going to emit. It needs how the size of the particles, the direction that the particles are going to initially go in, the lifespan. Oh, and here's the number of particles we're emitting. Let's do 30 just to begin. Okay, now all I want to do is set a breakpoint here and step into it and make sure it's running. All this other, the update and the draw, that's all going to be something we need. In fact, let's go to the emitter and make sure that we are sending, see the draw, we got to send the canvas into there. Okay, let's run that. So what I just did is I went to the emitter and I went to the draw function and I added the canvas, because it's going to behave just like a particle, except for it's going to be a particle of particles. Yeah. And we're just going to call it emitter. So it's just going to have a list of particles inside of it. Okay, start debugging. Let's see how bad this crashes. Step into, boom. Number of particles, 30, good. Good, 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 good. Okay, good. All right, let's look at that. All right, great. We're not doing anything in the draw yet. So let's go back to the emitter code. And we're going to start knocking this out. What do we need to do before we can update and draw? Well, we need a list of particles. That's what we need, is we need some particles to update and draw. So, to do that, we need to be able to add particles that are renewed from the memory pool, and we need to create particles from the memory pool. So this is just going to be called once, and its whole job is to pool the memory for the emitter. So what we'll do is we'll call that function here. We'll call that function down here for pooling the memory. So what we'll do here is we'll do self.pool memory. Okay, because we need to create a memory pool of particles to emit from. And we're going to do that with our list of particles. So let's create our memory pool. We don't need this guy anymore. We don't need this guy. What we need is a for loop. So we're going to actually we're going to port that. We're going to say for I in range self._particle count. Boom. Okay, that is done. That's ported. Done. Done. Okay, now there we go. Now, new particle, this is actually going to be, this is just going to be equals particle. That's where we're going to create particle. Well, how do we create a particle? We're not going to do get polar x, polar y. The particle that we're going to emit is going to be based on the location. So we're going to just say self.location.getX. And then self.location.getY. This is just our starting location for our emitter, which is where we instantiated the emitter. We gave it an x and y coordinate for beginning with. Okay, now this is just going to be the width of the emitters, the particles that are going to be passed down to the particle. Now remember, we do not have the angle that we're implementing, so we're going to get rid of that. We are going to have a direction. Okay, and then I don't know what this is. Let's look at our particle constructor. Let's grab our particle constructor. And, oh, I know what that is. Okay, we're going to go back to the emitter code. And we're going to put down the particle, what's needed in the particle emit. So what we're going to have is we're going to have particle height, width. We got that. Direction. We got that. We do not need the particle count yet. We may need to add that. But this -1 is for the lifespan. Because what we're going to do is we're going to just instantiate a pool of memory, and you need to have pools. So if you're building a game that's based on managed programs, managed software development kits like JavaScript, Java, C#, Python, those ones are all managed. You don't want to always be instantiating particles all the time through your game loops because it's really inefficient. So what you do is you pool your memory, and so this is essentially a memory manager, and we're telling it that these particles we're instantiating are dead. That the lifespan is -1, therefore they're not going to be drawn on the screen when we update the particles and we draw the particles. And we only draw the particles in from the memory pool that have been renewed and are showed to be alive, because that's how a particle system works. So we're essentially just creating a list of particles to be used. And we're not going to use all the particles at any single time. We're going to be renewing them, and they're going to die. Then we look for more to renew, then they die. Then we grab more to renew, and then they die. And the ones that we renew are being drawn to the screen and updated. So that's what that -1 is for. Okay, I think that is fairly ported. Okay, now why doesn't it like it? Oh, because it's not defined. So we need the particle include here too. Let's just grab this one and call it particle. Okay. There we go. We got it. So now we can test the pooling of the memory. When we call it, and we can look at the particles, but the particles need to be part of the init. So that's got to be up here. So this is the particles that we put in our list. So when we instantiate them, that's like adding them to the list. So this code is probably needs to be redone a little bit. No, it's creating the list and it's adding the particle to each item in the list. We just need to pool the memory, look at what it's doing, and examine that pool memory function to see if it works. So I'm going to set a breakpoint here. In main, we instantiate the emitter, and then that should trigger that breakpoint. So I'm going to start debugging. There, let's do a step into. Let's do a step over. Let's create our first one. Now let's look at our particle. Oh, it went right back. Okay, let's look at our emitter class and our globals and look at the particles inside of her. There's our emitter. So what we'll do is we'll just grab that and put it in our watch, and we can look and see if the particles are instantiated inside of it. So I'm going to bring that down. I don't think it's in special function variables. There we go. Particle. Is it going to even give us? No, you silly goose. Okay. Let's hit continue and see what happens. Oh, it died. All right. So we've got a little bit of issue. I'm going to go back and review and see the best way to instantiate a particle onto our list. I'm probably just using it wrong. Yeah. So I'm not going to take you guys through that. I'm going to come back and give you the solution once I see the appropriate way to add a particle. I think it's just append. I think we could just do append. Yeah, append. I think that will actually work. Oh, I got to have us close out here. Okay. All right. Let's see if it dies. Let's just run it. Oh, wrong thing. I'm going to say that we got particles. I think we got it. I think we're good. Okay, well, I'll fix that. That was quick and easy. Now what we need to do is the emitter, what its job is going to be is to, we're going to want to add particles every so often. And what we need to do is we need to add particles probably from the game loop. And then the add particles will be what actually renews the particles so that they can be used and drawn in the update and the draw functions. So this is the add particle that essentially what it does is the particles are already in the memory pool. What it does is it's going to renew the particle so that its lifespan is greater than 1 so that we actually draw and update it on the screen. Because the pooled memory of particles is always going to be there. It's that lifespan that we're using to control whether that particle is active on the screen or not. And so this is the next thing that we got to port. And what we need is we need a variable that finds a particle that can be renewed. So we got to go through the whole memory pool and find a particle that has its lifespan less than 0. And every particle reduces its lifespan. So if we go over here and we look at the particles, the update of the particle, you see it reduces the lifespan. So that's what we're working with here is when we emit, we are working with that lifespan value. So we're going to say found is a true or false variable for whether or not we found a particle that can be renewed. And so what I'm going to do here is I'm going to say for I in range count. And count is how many particles we're looking to renew. Okay, that's done. Now what are we doing? We are going through all the particles. So this loop is to find an empty particle to renew. And for every particle that we're looking for, we need to go in and look at the particle list to find a particle that we can renew based on its lifespan. So what I'm going to do here is this is going to be for J in range, and this is going to be the length, the amount of particles we have. So this is going to be the particle count value that we send when we instantiate the emitter. So when we instantiate the emitter, we're sending it. This should be a lifespan of thing. Let's build three. Let's put 300. A lifespan of 300 and 300 particles that should be renewed, or 300 possible particles available in the memory pool. And so that's what that last number of particles. So we're going to have 300 particles in the memory pool. So that's going to be the count, particle count that we're using. So this is going to be in range particle count. So we're going to go through in range particle count. Particle underscore count. So that's going through all the available particles in the memory pool. And then what we say is, hey, if that particle is dead, then let's renew it and start drawing it on the screen. If the particle of J is dead, that means that we're calling the particle and we're saying, hey, is its lifespan that we reduce every time we update it, is it less than 0? Yeah. Oh, we can start drawing that particle. And the emitter is going to control what particles are drawn or not. So only if it's dead do we want to actually renew that particle. Now this is going to get into some intense code where we're going to randomize a direction of where we're going to disperse that particle. So let's do this. We're going to set the direction of the particle, and remember, a direction is just a p-vector with a set function. So we're just setting the direction the particle is going. And what we're going to do is we're going to randomize that. We're going to randomize that just so we can have a good pattern. So we need to get a random variable in here from Python, and we probably need to seed it. But you know what I'm going to do is I'm going to pause this and get that code in here, and then we're going to just put it in this function only so you guys can see it, and then you can implement it from what I come up with, and I'll be back soon. Okay, we're back. So what I did was I added 2 imports, random and time. And then I properly seeded the random, because if you don't do that based on the epoch time, that's a unique number every time in milliseconds, that's what's needed, then your gaming, the Gaming Commission in Las Vegas will fail you. But here's what we need is we need to randomize floating point numbers, and you use the random.uniform function to do that. And then what I did was I tested this so that I knew I was seeding properly, and then I called the random. I looked at X and 1.52, so it is between those values. And I want a floating point number so that everything's kind of more organic in there, even though we convert everything back to integers eventually. So this is ready to go. These 2 lines of code and this 1 line of code, so that we can implement this line of code when we add particles, so that we can set them to go from in a specific direction based on whether or not the particle is available to renew. And all the renew does for a particle, let's go look at that. All the renew does is set the location and the new direction, and then it goes from there. I'm not sure we're going to need this. This is, oh yeah, because we just want the acceleration. The velocity is going to be updated based on the acceleration. So it's just kind of the starting direction of its acceleration, which will eventually, the velocity will be the acceleration. So that's fine. So all it does is update the lifespan, and so that we can make that particle that's in the memory pool alive, so that it's our update and our draw functions will actually update and draw them. And then we're going to be adding that into the update draw functions, so that they only draw them and update them. Oh no, we're going to do that from the emitter, so that it only updates and draws the particles that are alive. Okay, so then we're going to go back here, and we're going to, when we renew a particle, we're going to set a direction. So we're going to use this randomization code and port this JavaScript code to the new randomization, but we're going to use the old numbers. So we're going to say 0.5, 0.5, and 2. So that means it's going to be going to the right and down, and it's going to randomize between those numbers. So it's going to fan in like this direction. Each one will have a different direction based on this between these two numbers. And that's just for the x. So that's for the x value. And then the y value, we're going to do the same thing, but it's going to be between -2. So it'll be like, it'll go, so the x value will be between 0.5 and 2. So it'll change, it'll have different speeds. The y value will create the fanning so that it is either goes up or down to the left or right. So we're going to do this. Cool. So then the next thing that we need to do is we need to tell our particles that in the pool that we've found that is dead, that it's now alive. This particle, we're going to renew it, and we're going to send it a new lifespan through the add particle function that we're going to call. We'll probably call that from the game loop. We'll add particles as the loops are going, and then they'll die out. So every time the game loop is called, we'll add some particles, and then they'll die out, and we'll add some more particles. And then we said that we found a particle to renew. And then if we found a particle to renew, let's break out of the for loop because we don't want to go back in. And I don't know if we actually even need that found because we're not actually using it. Because we're using the break to get us out of there. Yeah, let's get rid of it. We don't need it. Okay, let's get rid of this. Okay, there we go. We have our add particle function so that we can add particles from the memory pool that will be redrawn and updated. So now what we got to do is we got to go up to the emitter update, and we update all the particles every time so that their lifespans are reducing, etc., etc. And so that all the particles update and they bounce off the screen and their lifespan is reduced. So what we'll do is we'll go back to here to the emitter and we'll say for I in range particle, how many particles are there? And then what we'll do is we will update all those particles. And I don't think we need to send anything into the update function for a particle. Oh, this is not tabbed in right. There we go. Oh, that's why. Okay. Because I didn't finish that up. Okay, now if I look at the update for the particle, there we don't send it something. So we get rid of that. And we just, every time we update the emitter, we go through and update all the particles that are in the emitter. And the emitter is going to be updated from the game loop. Okay, now we draw. For I in range, we're going to draw all the particles. We're going to go through and draw all the particles It looks like we're just going through and doing all the particles. That's interesting. We'll see how that goes. Oh yeah, because that makes sense, because they're only going to be drawn. We should have probably, this is gone. This is, we don't use angle. Oh. Why do we call an update there? Because it's being updated up here. We may need to do the update. Okay, we may need to play with that later. Let's go ahead and take it out for now. Okay, so if the particle if the particle is not dead, that's the only time that we want to draw. So we're going to loop through all the particles, and only if the particle is alive do we draw it. Okay, and this is our add particle function, and what we'll do is we'll probably take that and put that in the game loop. All right, I think we're ready to test this emitter. And what we're going to do is we're going to instantiate it, and then we're going to call the add particle function and add a particle every time through the game loop, or one particle or multiple particles through the game loop, and then we'll see if all this other stuff that we got built actually works. It looks like we got a problem right here. This should be self underscore underscore particles. And then this should be self underscore underscore particles. And then this can go away. Okay, we pull our memory from main. Oh, well, no, we pull our memory and we seed our random in the constructor, the init function. Then we can add particles from the main game loop, and the add particle renews them so that they're no longer dead, so that they will be drawn when we draw it, and it will always update particles. I may want to say just only update the particle if it's alive. So we may get rid of this. We may add, instead of updating from main, we may update down here in the draw. We'll see how that behaves before we get into it. But I think that we're good with the emitter. I'm going to just kind of take a pause here so you guys can take a look at it. Here's the emitter. There. Here's the particle. Okay. Here's the vector. Okay, now's the hard part, guys. Getting it to work. So every time through the game loop, we should probably add some particles to update and draw. So this is going to be self underscore test dot add particles. Okay, and what particles are we going to add? Well, we instantiate it down here at 551616. So that's hard coding it. I don't know if we should hard code, but let's change this to 10 to the right and 150 so that it's in the 300, so it's in the middle of the screen to the left where we're emitting the particles. And then what we'll do here is we're going to add, every particle is always going to be added at 10 300. Okay, and then our lifespan, when we add a particle, that should be this guy that we're passing in. We're probably not using it. Let's just do 300 just to play around with it. And I think I think this is 3 particles. So let's look at the add particle function. Let's go over here to the emitter. Let's go to add particle. And let's just grab it so we know what we're dealing with. And the add particle, it's going to be our initial direction, but the direction is going to end up being overridden down here. So it doesn't really matter much what direction we send it. So we can just hard code that from what we did in main. We can actually just set it to 0, 0, I think. So let's go ahead and do this. Let's put a comment in here so we know we're going to have some messing around to do. So direction, let's just do this. Let's create a p vector of 0, 0. So it's basically directionless. Because if we go back to the emitter, we're expecting a p vector there. Because we say set, and then we send it. So we're already just overriding it. So we actually probably don't even need to pass that. In fact, I would probably just want to get rid of that. Unless you wanted to override that from the emitter. But you would still want to put, yeah, okay, it's fine. Let's just hard code it. We know it's getting overridden, whatever. The hell with it. You guys can play with that if you want to. We don't really need it. That's fine. All right. So then the next one is, so direction of nowhere. X and Y start at 10, 300. So to the right in the middle of the screen. And then how many particles are we going to add? So we're going to say add 3 particles every frame. Okay, I have no idea if this is going to work. Let's set the deep breakpoint and let's just run through it before we just let loose on it. Okay, I'm going to do a step into. Okay, oh, okay, well, all right, good. Count. Okay, so this is count. It's going to find 3 particles to renew. There we go. Particle count. There it was in our first error. There we go. 1 underscore. I knew it was going to happen. Let's just set our breakpoint here. So that when we go back to main, we don't have to do a step into, and we just run. Okay, there we go. Count. We find, okay, what's going on there? Has no attribute particles. Oh, I did it again. Okay, 2 underscores. All right, stop. Let's go back. Main. Start debugging. Okay, step over. Good. Good. Angle. Ah, I did it again. The renew does not need an angle for the particles function. So now we got to go look at the renew. So let's go look at renew for a particle. It's just direction, x, y, lifespan. We're not using an angle. So let's take that out. Right there. So that goes away. That's part of porting, guys. Just, yeah. Okay, let's do a save all. All right, let's go to main, run it again. Okay, X. Oh, XY. Why does it not like the p vector attribute? X. That's got to be something in the renew function. Okay, so let's get rid of this breakpoint. Let's step into the renew. Okay, now I'm going to step into the renew. Okay, X and Y, 10 and 300. That should work. Okay. Direction. Oh, there it is right there. That's the problem. That should be get X and get Y. Okay, we'll set our breakpoint here. Run, start debugging. I'm just going to hit continue here so it goes to our other breakpoint. There, we're on our renew. Good. Good. Lifespan of 300. -1, that's where it starts out as in the memory pool. Good. We found our first particle to add to the to renew from the memory pool that's going to be drawn to the screen and updated. Okay, we go through, we find another one. Boom. We got 3. We should come out of this. Good. 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 Okay, let's do this. I'm going to get rid of this breakpoint. This is what I want to check next, is I want to check that. So I'm going to hit continue. Let's step over. Ah, that's another error. Underscore. Okay, so that's in our emitter update. Okay, let's check this one, and then we got to check the draw. Okay, let's remove this breakpoint and hit continue because we've already checked the renew. It's good. Okay, let's step over. That's good. So let's hit this one, hit continue. Now let's check draw. Particle draw. Missing one required positional argument. Canvas. My mistake. We forgot when we have our draw for our particle. Our draw for our particle needs the canvas. So guess what we got to do there? We got to send the canvas in. Okay, let's keep that breakpoint. Start debugging. Okay, step over, step over. Good. Okay, let's hit continue. Let's get rid of this breakpoint. Hit continue. Let's look at the screen. Oh, whoa! Awesome. Nice, guys. I think, yeah, that's not looking very cool. Because look at how it's kind of like doing this like stuttering thing. I don't like how it's stuttering. That's so old because it's running out of memory in the pool. Because we're grabbing too many at once. So let's do this. Every time through the loop, let's increase the memory pool. Every time through the loop, the game loop, let's just do 2 particles. Renew just 2 particles. Lifespan of, let's reduce the lifespan to 200. Down here, let's reduce the lifespan to 200. Let's increase, this is lifespan, this is memory pool. Let's increase the memory pool to 400. And you know, it's kind of slow, so you guys may want to play with this. But, okay, it's not stuttering anymore. But it's still slow. But, I mean, that's Python. We could reduce that to 1 every time through the loop, and it might speed it up a bit. Yeah, let's reduce this to 1. Let's have them go faster. Let's do this. Let's go into our emitter code. And right here, this is what describes the speed. Let's make it so that we can have some that are moving faster. And let's make it so it fans out a little bit more on the Y coordinate. There we go. Alright guys, this one's a lot of fun. I wanted to give you a little bit of some experience with porting, a little bit of some experience with why we have object-oriented programming, because as you see, this gets really complicated. But here's the thing, we were able to take a whole different technology built, well, not really different, but a whole different batch of code built in JavaScript and port it over to Python and implement it very simply. And that's why object-oriented programming took over. It's now the way everything's done. And it essentially, when you think about it, you're actually, when you're creating objects, you're not just programming, but you're also programming for the future. Think about that. And I'll go back to the example I have always used is before object-oriented programming, we would have new hardware. We would have to wait for a year for the software to be developed for that new hardware that we bought and probably spent $800 on. And we're sitting there waiting. Object-oriented programming, new hardware, the software was already created for the new hardware. The software was already created for the hardware that hadn't been even envisioned yet. Well, I'm being a little bit, yeah, okay. Programming for the future, guys. And then easy porting, easy updating, easy everything. All right, that's it. Before I leave, let's just take a quick run through on everything. I'm going to go through main. Here's main. That's it for main. Particle. Now let's start with p-vector. P-vector. Particle. Emitter. And more could be done with acceleration and velocity if you want to add forces to this and have them behave a little bit differently. But other than that, we are at a finishing point. Have fun with this one, guys. You can continue on with playing and learning more about 2D games. One thing that I would encourage you to do is try to take one of these particles and instead of drawing an oval, draw an image. That would be your next step. And then how could you animate that image of that particle, and in fact rename it sprite instead of particle. And then if you really want to know how to make it move around like a character in the game, take my CS262 programming course. We do that all in JavaScript. And you can learn more about character animation and a little bit on collision detection and you know, some of that other stuff with the JavaScript language. All right, guys, take care. See you later. Bye.